My name is Vanessa Casillas. I am doing a video walkthrough for problem 2 of exam 2. And so for this problem, what we are trying to find is information on the different study habits of students on campus. So students tend to study at about 180 minutes a week with a standard deviation of 30 minutes. And from collecting our studies, we know that each study has roughly 25 students. And so what we are looking for is the probability that the mean time meets these different requirements separately. And so for the first, before we solve, we need to establish our equation. We're going to be using this equation, z equals x minus mu over standard deviation divided by the square root of n. And given this information, we're able to identify most of the information. So we know that mu is 180, standard deviation is 30, our sample is 25. And so we are going to use this information to solve parts A through E. And so starting with part A, we know that what we are looking for is the probability that the mean study time is less than 171. And so 171 will be our x. So we are going to take 171 minus 180, the mu, and we are going to divide this by 30, our standard deviation, which in itself we will divide by the square root of 25. That leaves us with negative 1.5. And when we look that up on our z table, we end up with a result of 0.0668. And so that is our answer. For B, we are looking for between 168 and 180. So we will have two x values. For the first one, we will repeat what we did in A. Our x will be 168. And we end up with a result of negative 2, which when we look it up on our z table, we end up with 0.0228. And then from there, we will do our second equation, 180 minus 180. X is equal to our mu. And so because of that, our numerator will be 0, and hence the whole answer will be 0. But that means that when we look it up on our z table, our answer is 0.5. And so we will take these values, we will take the larger value and subtract the smaller value to get 0.4772. And that is our answer for between 168 and 180. For C, we have identified our x value as 183. So just like before, we will put that in as our x value. That will give us a result of 0.5. And when we look that up on our z table, we will get 0.6915. But because we are looking for a greater than value, we will subtract that. We will take 1 minus 0.6915, and we will get our result of 0.3085, and that is the between value. So moving on to D, we've identified our x as 160. We're looking for at least 160. And so to look for at least 160, we will take 160 minus 180. We will divide that by 30, divided by square root of 25. We will end up with negative 3.33 and so on. And that will give us 0.0004. But because we're looking for, once again, a greater than value, we will take this 1 minus 0.0004. And that will give us our value of 0.9996. And so going down to E, where we're looking for less than 160 or more than 191. This means we're looking for the ends of the distribution chart. And so to solve that, first we're going to look for 191. So we will take 191 minus 180 divided by 30, which in itself will be divided by the square root of 25. That will give us a result of 1.83. And when we look that up in our z table, we will get 0.9664. But because we are looking for more than, greater than, we will take 1 minus 0.9664. That will give us our total of 0.0336. And because we had already solved for 160, we are going to reuse the value already found here and plug it into our equation here to get 0.0340.